Today I am going to talk about transistor audio amplifier, power audio amplifier, which has very low distortion. And here I am going to show you the circuit. This is the power amplifier. You can see the differential amplifier, current mirror, VAS stage, some biasing network, some basically sources, current sources. Then comes the F2 stage or double emitter follower. This is the preamplifier circuit, and this is the final circuit. Well, this is a BTL amplifier, and basically in a BTL amplifier the speaker has more power than a single-handed amplifier, basically by 4 times. But then if you used basically 2 amplifier hands connected somehow such that it basically generated the inverse signal to drive the speaker, well, there can be motorboating distortions. So to avoid that, I am using preamplifier, and this is the circuit. So basically preamplifier have high gain to basically amplify any signal, audio signal. And basically this is the preamplifier. It has very high gain set by these 2 resistors, and it is basically inverted by this circuit, this amplifier, and it has a gain of 1 or unity. So basically if the signal is going up here, the signal will go down by the same amount here, and it is given to these 2 power amplifier or power op amp, and it drives the speaker. The power op amp should not add any noise or distortion. I am also using this 4-band equalizer board. It is very simple. Basically the audio signal comes to these potentiometer, and they are connected to ground, and the wiper basically sets the volume of the signal, and basically this slider is connected to several band pass and high pass low pass filter. So basically the first is the low pass filter. It basically boosts the gain. It does not boost the gain, but basically makes the low frequency appear in the final signal. This one is the mid low, this one is the mid high, this one is the treble. So basically you are cutting some frequencies, or basically you are adding it, but you are not amplifying the signal. So basically the preamplifier should have very high gain to basically overcome the losses by this equalizer. So I am not using 27 kilo ohm resistor here. You can use 68 kilo ohm or 56 kilo ohm. The advantage of the BTL design is that there is no cap connected from the speaker to the ground, which is actually nice. But then if you connect the speaker to the amplifier directly, the issue is that if the amplifier is not biased correctly, or there is some error, the speaker may see a voltage across it, which is not very nice. So you need to verify before connecting the speaker. But the main basically advantage is the power. With a very low voltage supply you can reach very high power, because the speaker can see the plus. Basically if this node is plus 12 volt, this node can be 0, and if this one is plus 12 volt, this can be 0, and vice versa. So that's why the speaker sees basically double of the voltage swing than a single-handed amplifier. But then it adds complexity. This amplifier alone has 32 transistors but very low distortion. To make a cheap amplifier, you can of course use the circuit. There is no basically current mirror, just a resistor, then this basically transistor. And it is very simple. You just need to increase the voltage here and use a current source or current sink here. Actually not current source, you can use a current sink here, CCS, to basically set a minimum current and drive these transistor in a high current region, and use a higher gain transistor here. Then you can achieve maybe 10-20 watts with 24 volts or 30 watts of power supply. But with this design you can reach 18 watts at 12 volts, but since this is not rail to rail, it can be limited. I am limited by 6 watts because my power supply can only output 6 watts, but it can output much more than this. Now I am probing at the output of both the amplifier. So my ground goes to ground, one of the probe goes here and other here. Now I will play a song. You can see how basically if one of the trays go up, the other goes down by the same magnitude. That creates symmetry and basically it increases the power. Now I've connected my scope probe here and ground here, and this is the yellow trace. And let's see, basically we'll see some negative and positive thing. You can see there is very little offset, but it doesn't matter. It is in basically millivolts, less than 50 millivolts. It is reading these spikes, which doesn't matter now. This can be interference, of course. This is what the speaker sees. And of course, I can decrease the bass. I can just boost the treble. I can basically pass mid-high. Or I can pass the bass. Or I can pass everything. Now about the output transistors, I'm using TIP 3055 and its complement. I can, of course, I forgot about the complement transistor. You can see its marking. It is TIP 2955. This resistor needs to be 4.7 kilo ohm and this one needs to be 1.8 kilo ohm to create a voltage difference of about 2.4 to 2.5 volts maximum. It can go as high as 2.6 volt, but remember these are power transistor, so their high current base to emitter voltage drop is higher. And thanks for watching the video. I hope you liked it.